In this video, I cover how to solve quadratic equations using the quadratic formula, as well as how to solve for and plot points on a graph of a parabola. I'll also cover the vertex formula and show you how to solve for the intercepts of a parabola. If you find this video helpful, please like and subscribe to my channel. Now let's get to the problems. This next problem involves simplifying in order to solve a quadratic equation. So remember, your quadratic formula is that x equals negative b plus or minus square root of b squared minus 4ac all over 2a. And they're talking about the form of a quadratic equation, ax squared plus bx plus c equals 0. So in this case, a is 4, b is 7, c is negative 1. So when you plug those in, opposite of b, which is negative 7, plus or minus square root of b squared minus 4 times a, which is 4, times c, which is negative 1, all over 2 times a, which is 2 times 4. So we just need to simplify this problem. Negative 7 plus or minus square root of 7 times 7 is 49, and negative 4 times 4 is negative 16 times negative 1 is positive 16, and that's all over 8. So simplifying further, we can add the 49 plus 16 to get square root 65, and that's all over 8. So the final simplified answer is negative 7 plus or minus square root 65, all divided by 8. The next problem is asking us to graph a quadratic equation. It's quadratic because we have x squared here. Remember, when the highest degree of the polynomial is a 2, then it's a quadratic equation, and those graph into a parabola. So typically your parabola is like this or like this. Okay, so if we can find the vertex, that will be very helpful, and then finding the axis of symmetry helps as well, because that will divide the left and the right sides of the parabola. So this particular problem is asking us to solve for some ordered pairs. So it's giving us negative 2, negative 1, 0, 1, and 2. So they want us to plug in all those for x and simplify all this in order to get the corresponding y value. So in other words, for the first problem, y equals negative 4 times negative 2 squared. Negative 2 squared is 4 times negative 4 would be negative 16. The second problem, y equals negative 4 times negative 1 squared. So negative 4 times 1 is negative 4. When x is 0, y would also be 0, because 0 times negative 4. When x is 1, we can multiply 1 times negative 4. So we have two negative 4 values, and that's a good thing when you have two y values at the same height, because then you could figure out that your axis of symmetry will be right between these two x coordinates, and halfway between those two x coordinates, the midpoint of negative 1 and 1 would be 0. So we know this will actually be the vertex, and that's important in graphing the parabola. So whenever you see two y values that are the same height, essentially, you can look at the x values and find the number right in between them, and that will be the x coordinate of the vertex, which means this is the y coordinate of the vertex. Now let's solve for this last value, negative 4 times 2 squared. Negative 4 times 4 is negative 16. So I'm just going to graph a couple of these. 0, 0 again is going to be our vertex, and we could see that anyway when we plot a few of these, like 1, negative 4 is down here, and negative 1, 4 is here. So I'm not going to plot the negative 2, negative 16, and 2, negative 16, because those will be going off my graph. But let's go ahead and connect our parabola. Basically, in this case, your axis of symmetry is the y-axis. For this quadratic equation, they're asking us to solve for all the intercepts and graph. if we plug in 0 for x, we can find the y-intercept. So our y-intercept is going to be found by y equals 0 squared minus 6 times 0 plus 10, which is 10. The coordinates of our y-intercept are 0, 10. Remember, you solve for x-intercepts by setting y equal to 0 and solving for x, and you solve for y-intercepts by setting x equal to 0 and solve for y. If we wanted to set y equal to 0 now to solve for x, we would get this equation, but that's not factorable since negative 2 times negative 5 aren't going to add up to negative 6, and neither are negative 1 and negative 10. So it's not factorable. In order to solve this, we would probably want to use the quadratic formula. So x equals negative b plus or minus square root of b squared minus 4ac all over 2a. The opposite of b is opposite of negative 6 plus or minus negative 6 squared minus 4 times 1 times 10. So you'll have 36 minus 40 under the square root, which will give us imaginary answers. So because these are going to be imaginary, they're not going to help us with our graph. So at this level, we're just going to say these are imaginary, and I'm not going to go ahead and I'm not going to solve those any further. So basically what that tells us when our solutions are imaginary is that our parabola will not intersect the x-axis. So it's either this type where you have a parabola above the x-axis facing up, or it's this type where you have a parabola below the x-axis facing down, because it's not intersecting the x-axis. A key point is the vertex. So let's solve for the vertex. Now the vertex can always be found by an x-coordinate of negative b over 2a, and then plugging that in for x, which is called f of it. So we'll get this value, then we'll plug that value in for x and solve for y. And that'll give us the coordinates of the vertex. What is negative b? Well, if b is negative 6, then negative b is negative 6, which is 6. The x-coordinate of the vertex is negative b over 2a, which is negative 6, over 2 times 1. So we're using these two values, a and b. We're plugging them into the vertex formula, and we get 6 divided by 2, which is 3. That tells us the x-coordinate of the vertex is 3. So how do we get the y-coordinate? Well, we plug that in. That's what f of that number means. You plug in the 3 for x. So the y-coordinate of the vertex is going to be at 3 squared minus 6 times 3 plus 10. And that would be 9 minus 18, which is negative 9, plus 10, which is 1. So the coordinates of our vertex are 3, 1. So next, let's go and graph this parabola. That will be a point on the parabola, 0, 10. That's our y-intercept. And 3, 1 is the vertex. 1, 2, 3, 1 is the vertex. So that's another point on the parabola. And keep in mind, the axis of symmetry always goes through. So this is not part of the graph. It's just what we reflect over to get another point on the graph. So we can reflect this point that's up here at 10 all the way across to get a new point. And if you say, well, how do we know what that new point is? Well, from our vertex, we could get to this point 10 by going left 3 and up 10. So if we go right 3 and up 10, we will get to another point on this parabola. So let's go ahead and graph the parabola now. I'll do that in purple. And of course, these should be smooth, U-shaped curves, but that's just a rough sketch. For this next quadratic equation, they want us to solve for the vertex and the intercepts. Remember, we can solve for the y-intercept by setting x equal to 0. So y equals negative 0 squared plus 10 times 0 minus 9, which is negative 9. So the y-intercept is found at 0, negative 9. To find the x-intercepts, we can set y equal to 0, and this problem looks like it might be factorable. So I'm going to factor out negative 1 in order to make my x term a positive inside the parentheses. And then I notice that it is actually factorable. X minus 9 times x minus 1. Negative 9 times negative 1 is positive 9, and negative 9 plus negative 1 is negative 10. Setting all three of these factors equal to 0, we can see that this is an extraneous solution. 0 equals negative 1 is false. You can add 9 to both sides and add 1 to both sides. So this is giving us some intercepts. When x is 9, y was 0. And when x was 1, y was 0. And the third intercept is 0, negative 9. Okay, so you have your two x-intercepts here. And again, those are found by setting y equal to 0 and solving for x. You could still plug those into the quadratic formula. I just found it a little bit easier to factor this one since it's factorable. Next, they wanted us to find the vertex. So the vertex is always found, the x-coordinate of it is found by negative b over 2a. That's the formula. Since a is 1, b is 10, so negative 10 over 2 times negative 1. Negative 10 divided by negative 2 is 5. So the x-coordinate of the vertex is 5. We just need to find the y-coordinate of the vertex by substituting 5 into the original problem. So y equals negative x squared means negative 1 times x squared. Our x that we're plugging in here is 5 plus 10 times 5 minus 9. So we get negative 25 plus 50 minus 9, and 25 minus 9 is 16. Since it's a negative, that means it opens down. Since a is a negative number, it's negative 1. Our vertex is over 5 up 16. These are our two x-intercepts. The y-coordinates are the same height. Then right in between the x-coordinates, so halfway between 9 and 1, meaning 5, is where the vertex is found. Plugging in that 5 for x, you get the y-coordinate of the vertex. So we have 4 points on that parabola, and that would be pretty easy to graph. I encourage you to try all these problems again and see if you can verify them on your own. Thanks for watching this video. Please subscribe for more math tips.